I didn't realize I was capturing already. Okay. The process I was showing you yesterday where we're canceling units. Let's see, what I used yesterday was carbon. Let's use something else. Well, actually, I'll tell you what, we'll use some density here. And I want to give you a copy of these test references here shortly, but you don't really need them right now, so I was kind of waiting a little bit. Let's take a look at, here's the density of gold on this reference, okay? And the way this is listed is 1.54 grams per cubic centimeter. Well, cubic centimeters is the same size of volume measurement as a milliliter. And so when I read that, I know that gold, which has the symbol AU, that if I have, where's that measurement again? If I have 19.31 grams of gold, that's going to be equal to 1 milliliter volume of gold. Okay? 19.31. I don't know why I used a colon there. All right, so suppose that I have 2.00 grams of gold. And what I want to know is, what volume would that gold displace? There's a famous Greek scientist who figured all this out, and he was actually trying to figure out whether a crown was made of gold or not. Anybody know who that was? You don't remember that story? I'll have to find that story for you. Okay, so supposedly he was in a bathtub, figured it out, and he was so excited about figuring it out, he went running through the town naked, yelling, "Oh, I figured it out."
Gold heavier than water.
Oh, gold is heavier than water, sure. Yeah.
So couldn't he just put it in the bathtub and it was
Well, that wouldn't tell you the overall thing, because that would tell you could actually measure the amount of volume that way. It's called displacement, but you couldn't measure the mass that way. But if you compare the mass and the volume, you get a density, and that's how he figured out displacement. He didn't actually technically figure out density, but it was kind of the beginning of understanding density. Okay, and so supposedly, according to the story, the Greek king who wanted this scientist to figure this stuff out got the guy who made the crown and killed him because it wasn't actually made of gold. Somehow he stole the gold or something. Okay, I'll find the whole story for you if I can remember to do that. Okay, so what we're going to do is we're going to put that over 1, and we're going to take this equality statement, and this right here is called an equality statement because I have two values. One is equal to the other. So we call it an equality statement. Does that make sense? Give it a name. It's called an equality statement. We're going to use this a lot in this class. Equality statement. Okay? And anytime you build a conversion unit, you have to first have an equality statement. All right? In this class, it is required that for you to have a conversion unit, you must first write the equality statement to justify it. Okay? So this is an equality statement right here. All right? So from that equality statement, I can build a conversion unit. And a conversion unit in this class is a fraction. Okay? What I want to do is to look at the beginning amount, or whatever amount I have remaining in the problem that hasn't been canceled already. In this case, it's the beginning amount. And I'm going to look at the units of measurement and the species. Then I look at the matching side of the equality statement, matching in the sense that it has the same units and species. Well, that's this side right here. Is there anybody that doesn't understand what I was just telling you to look for? Okay. Notice that the starting amount has units of grams and a species called gold, right? You can see that. Well, this side of the equality statement also has units of grams and the species of gold, right? So that's what we want to identify. Which side of this equality statement has the same units and species? Yes? I just made it up. I said, suppose we had that amount, okay? All right, I didn't look it up somewhere. It's just, I said, this is the amount we're going to start, okay? All right. Let's just say, for the sake of argument, I went back in the lab and measured it. How about that? So once I identify the side that has the same units and species as what is remaining in the problem at the time, then I want to put that side on the opposite side of this fraction. So in this case, since this is on the top, I want to put that value right there on the bottom. Okay, have I left anybody behind at this point? You want to match. You want to find the matching units and species. take the value that goes along with that and put it on the opposite side of the fraction here. Okay? So this part is going to go on the bottom, 19.31 grams of gold. And the other side of the equality statement goes on the top, 1 milliliter of gold. Okay? Now this is the setup. So hold that in your brain here for a minute. We've set up the problem, okay? Because I want to step back from it just a little bit and explain why I can do that. Everybody with me? I don't want to leave you confused, but I want to step back from the problem for just a second. But just remember where we are. All right? Anytime I have two things that are equal and I put them in a fraction, I need to know what is the value of that fraction. For example, suppose I put, let me mark this off because I'm not working with this anymore. Suppose I put 2, which is equal to 2, right? Would you everybody agree that's true? Okay. And I put those in a fraction like this. What is that fraction equal to? 1. Oh, good. See? All right. Suppose I have 1 dozen. And how many is that equal to? 12. So if I put 1 dozen over 12, and say these are eggs, if I divide those, what do I have? 1 egg. Okay? Well, actually, I don't have any eggs because eggs are going to cancel. But I have 1. So the upshot of this is, the main idea here is, anytime I put things that are equal on the top and bottom of a fraction, the fraction equals 1. Yeah, okay. So, and I multiply something by 1, the answer's got to be the same as I started with. Is that right? So what I'm going to do is I'm going to use this process to change how I've measured it without changing the amount. You got that? Conversions change how you measure something without changing the amount. If you want to know what a conversion does, and it's a good thing to know, a conversion changes how you're measuring something without changing the amount. It probably is. If it isn't, I need to put it in there. Okay? A conversion is a process of changing how you measure something without changing the amount. So really what I did here was to take something you already knew, that two things that are equal, you put them over on a fraction, they equal 1. You knew that already. I just had to put it down for you in a way that kind of illuminates this, right? You knew that. Here's something else you knew. If I have an x value from algebra, and I multiply that x value times y over x, what's the answer going to be? Y. Why is that? The x's are going to cancel out, okay? And the answer is going to be y. Well, that also applies down here to our problem, okay? I can cancel out the units of measurement. So grams are going to cancel out just like my x's canceled out up here, okay? It also applies to this species of gold. It cancels out just like the x's canceled out up here, okay? The result is that I get an answer in units of milliliters and species of gold. So this process then allows me to convert the amount of 2 grams to volume in milliliters without changing the actual amount. I just converted how I measured it. Okay? And all I have to do now is take this number and do what with this number? No, this would be division because it's in the bottom. Okay? If it were 2 things across the top, I'd multiply those 2. But what happens when I multiply 2 times 1? What do I get? 2. So instead of 1 right there, I really don't have to do the math, do I? Because you know what it is, right? As long as we have ones, we can kind of ignore the ones. Right? So I'm going to take this number and divide it by that number to get an answer. So how many of you have a calculator yet? If you have a calculator yet, you need to get that out because you need to practice. The more you practice that calculator, the more equipped you are going to be to do well on tests in here. And by the way, when we get to the Unit 1 test, you are going to need a calculator. So make sure you get your calculator. Well, you're supposed to have it by Monday anyway. Okay? All right, so we take this 2.00 and we divide by 19.31 and hit enter. And I get a great big large set of numbers. Can you see it on the screen? Okay. A lot of numbers. Okay, well, let's see how we're going to treat that then. All right, so 0.103573278. And it's required that you write down all the numbers you have on your calculator screen. That's required. Okay? What we want to do now is to figure out how to round this properly. Okay? So what we said previously about multiplication division is we choose the measured or calculated number with the least digits. This is a measured number. Now, I didn't actually go to the lab and measured it, but I said, suppose I did, right? Okay. So this is a measured number. This number was probably calculated, but it's got decimal places, so you know it's either measured or calculated probably, more than likely. And as we do more of this in this class, you'll be able to figure out a lot more quickly what are measured or calculated numbers or what are counted numbers. Okay? So we're going to look at only the measured or calculated numbers. We're going to ignore the counted numbers like this. Only the measured or calculated numbers, and look at the one that has the least number of digits, and we're going to write our final answer in that same number of digits. We have to use a process of rounding off that you are required to do in this class. So what we'll do is we're going to count the significant digits. Now I'm going to tell you right now that leading zeros are never significant. Okay? You listening to me? You got this? Leading zeros are never significant. Leading zeros are never significant. So when you study the unit handout about significant digits, I'm giving you a heads up. Leading zeros are not significant. And even though we haven't gotten there yet, I'm going to tell you that all these other numbers in here are potentially significant, but we're going to underline those that we're going to find out are not. So if this was not significant, this is the first significant digit. It's the first non-zero digit. Okay? Non-zero. Other than 0. Okay? So this has 3 digits. This one has 4. The final answer has to have the same number of digits as the one with the least digits. That's this one. Okay? So this is our first significant digit, second and third, and everything else has to be insignificant. And that's how we apply the rule for multiplication and division. Okay? So I'm going to underline everything after that third digit here in that problem, because we're going to ignore the first one. It's insignificant. All right, we underline them. Those are insignificant. I need to include my units that I have remaining. That's milliliters. And include the species. That's gold. Okay? And then I'm going to draw an arrow. The arrow says I am rounding this number off. You cannot use an equal sign because these two numbers are not going to be equal. We have to use an arrow to show a rounding off. And so the final answer is going to be 0.104. Very good. Milliliters of gold. And since I've finished the math, I'm going to put a period at the end and put a box here to tell the reader that's my final answer. Okay? So the underlining and arrow, that's required. The marking out of units and species, that's required in this class. Does that make sense to everybody? Okay? We're going to be using this process in a much more complicated fashion before the semester's over. So get used to this simple stuff we're doing here, okay? If you get it good now, you're going to be settled and ready for the rest of the semester on this kind of stuff. You're going to be using this all quarter and all semester long.